Okay. Hello, everyone.
Okay.
Whatever time of day it is, wherever you are. So today I'm going to talk just a little bit about some meshing strategies that you can use, and we're going to focus on using Qubit. Some of these strategies would probably also work if you were using LibGrid, but in general, we find Qubit is a little easier to get started with. It's got a GUI and a few things like that. So some of the steps that are involved in meshing complex geometry, first of all, you want to decide what geometric features are really important in your model. And this can include things like fault geometry, topography, any sharp structural boundaries, and also if you're doing volcanoes, maybe magma chambers or magma sources that may have complex geometry. So depending on if you're doing a 2D model or a 3D model, in 2D, you represent the geometry in terms of spline curves generally. Or if you're doing a 3D model, then you represent them in terms of NURBS surfaces. And you can do both of those within Qubit. And if you're going to use the surface in several different models, then it's usually handy if you can create the surface once and then save it for future use so you don't have to recreate it each time. And then once you have the surfaces that you need, you can use them within Qubit to web cut the various volumes in your model. And then finally, you have to decide on a discretization type, which could be the cell type, and also how you want the cell size to vary within your model. So the examples that we're going to be going through today, the first one is a two-dimensional subduction zone example using curves, and the location for the files that you need are shown here in red. So in this model, the geometry that we're interested in, we're going to have the top of the slab, we'll have the bottom of the slab, and then we're going to have topography and bathymetry. So that's a reasonably simple 2D example. Then we're going to do a somewhat more complicated three-dimensional subduction zone example, where in this case, rather than using curves, we'll be using NURBS surfaces. And that problem will be located here. And so for that problem, we'll be including the subduction interface geometry, and then we're going to include a splay fault in this problem. And then finally, we'll again have topography and bathymetry. And from the problem that we did with this yesterday, it turns out that some of the steps take a little while to complete on my laptop. So during the time that they're going, that's an excellent time to ask questions. And then finally, we're going to look at an example where we use Qubit sizing function that will allow us to vary the discretization size within our mesh using an external field that we provide. So this is what the 2D subduction zone problem looks like. And so what we have the subduction thrust here. Let's put it a little closer. And then we have the bottom of the slab. And then we have topography and bathymetry right here. It's pretty subtle, but it's actually there. And then we're going to have a separate region here where in the actual problem you would apply coseismic slip along that region. So that's the 2D example. This is going to be the 3D example we'll be doing, where we have the subduction thrust that we'll be creating a surface for. We have the splay fault, which we will also be creating a surface for. And then finally, we have topography and bathymetry. Then finally, we're going to be using a user-defined field to control the mesh size, and we can do this in two different ways. In the first example, we use a spatial database where the properties are varying vertically. And the way you do this is you first provide a uniform resolution mesh. You create that within Qubit, and then externally to Qubit, we define a field, and we do this using a Python script to apply the field to the mesh so that the mesh or the Exodus file then contains that field information. And then we go back within Qubit, create the geometry again, and import this mesh with the field into Qubit and create a new mesh where now the resolution varies according to the field that we provided. So this is an example where we did it with a spatial database, which would be an analog for, say, the shear wave velocity. You can also do it just with an analytical function, which is what we have here. In this case, we have an analytical function that we define. We apply it over the uniform resolution mesh, and then we take it back within Qubit and create a new mesh where the size, the cell size is now based on the function that we provided. So those are the examples we're going to go through today, and I'll start with the 2D example, which I believe is the simplest. So the first thing I'll do is we'll go into Qubit.